Hello and welcome. Another video on line coordinate geometry for year 12. It's only a tough question. This particular question will appear in the synoptic papers. I think it's on the paper Z now. It's the last three synoptics. I'm writing at the moment papers X, Y, and Z, and this will appear. They'll be available on my site, madasmaths.com. Sometime this July 2021. I'm very, very angry because I just finished recording the video only to realize I didn't press start, so I was recording really nothing and I have to redo it. So I'm gonna pull my hair, so I might be a bit snappy during this recording. Okay, let's see what the question is actually asking. We got 2 points, P and Q, coordinates 7, 5 and coordinates 4, -3. And what the question says is, if we rotate Q about P by 90 degrees in an anti-clockwise direction, what are the new coordinates of the point Q? All right, because you cannot see the picture and perhaps a lot of this might have gone over your head, myself included, the way we start this question is, of course, to start with the diagram, not to scale. If I need something to scale, I will do something to scale at a later, or relative scales, I should really say. We're rotating about P. P is 7, 5. Q is 4 -3. So we're rotating about P. This point in anti-clockwise direction by 90 degrees. So that's 90 degrees. So we're rotating a circle. So that will be the same as that. And this is the new coordinates, which we're trying to find. Pardon me, with my cough, even my cough annoying me. So this is the information, this is the picture. Question is, where do we start with something like this? So we start studying perpendicular, some do with gradients, equal lengths. We can find this length and then set this length perhaps equal to the length we found in there. Let's get going rather than talking. So first of all, grad PQ, difference in y over difference in x, 5 minus -3 over difference in y over difference in x, 7 take away 4, which of course is 8 over 3. Which now that means that the grad of PR is -3/8, negative reciprocal. Next thing is this gradient. PR must be equal to -3/8. I'm going to get an expression for that. So the gradient of PR, y -5 over x -7, y -5, x -7 is known to be -3/8. That's in fact the equation of your line. That's where it's coming from. The y minus y1 is equal to m bracket x minus x1, or I use x naught. It's the same thing. It's basically a rearrangement of some of this. I'm going to keep the minus with a 3, so we're going to get 8y minus 40 is equal to -3x plus 21, and rewrite it as 3x plus 8y is equal to 61. So the x and the y, the coordinates of the point I'm trying to find, they're not random. They must satisfy this relationship, which is a line. So essentially all it's actually saying, that's the equation of this line, which I marked it in dotted form, is 3x plus 8y is 61. I need another relationship. I need another equation. It comes from these little markings in there, which says this length, because we're rotating, we're going around in a circle, these are all radii. So first of all, let's find what the radius will be, or this length. So length PQ, boom, boom, is equal to difference in x from 7 to 4 is 3 steps on a coordinate line, squared. And from 5 to -3, again thinking of a number line, is 8 steps. So that is 64 plus 9 is root 73. So far so good. And therefore the same length, root 73, must be here. So we're forming a similar expression. So x minus 7, unfortunately now we have variables, plus y minus 5 is equal to the square root of 73. And if we square both sides, we have now a mess. We have simultaneous equations, one linear and one quadratic, but that's not the problem. The problem is this will produce two pairs of coordinates. So we won't have a unique answer. Unfortunately, the equations, when we are approaching the problem in this particular fashion, do not know about clockwise or anti-clockwise. So these two equations, one says the point must lie on this line and its distance from P must be root 73. So clearly there's two positions it could be according to these two equations. At the moment I cannot think of a mathematical way, a good mathematical way to deal with this problem, because when I have a problem like this, I won't be using this kind of method. I'll be using further maths, and I'll show you, in fact, it's a good idea to actually see the alternative method. That's for the further mathematicians, and appreciate the power of other things. And therefore, I will have my answer already by now and the correct point. So I hope I don't need my picture for anything else. So for the time being, I'm going to rub it off because the algebra in itself is quite painful. So I need to solve simultaneously these two lines. I'm going to rewrite this as 3x is equal to 61 minus 8y, first of all. I'm not going to divide by 3 because I don't want to create fractions. It's going to be a mess. Worse mess than what it already is. What I'm going to do, and it's good to actually see some of the more advanced, the more sophisticated algebra that one can do to solve problems. A lot of people, and it upsets me when I hear that. It says, oh, Dr. Madas's papers are a little bit number crunchy. They're just loads of number calculations. My answer to that, yes, there are at times, but it's not. Out of good arithmetic comes a lot of thinking and a lot, some of these tedious, perhaps, manipulations. They involve a lot of mathematics, and a lot of people go through maths degrees. They even do beyond maths degrees, and they cannot manipulate some algebra, which is really sad. Look what I'm going to do in there. I'm going to take this, round is over, by the way. I'm going to take this equation, I just wrote it in there, and I'm going to multiply by 9. I wonder if anybody can see my rationale. Why 9? Why not 10? Why not, 37? The 9 is related to this 3x. But then, why am I not times it by 3? I'm going to justify it here. I want to use this fact here. A squared b squared is equal to, of course, ab all squared. So if you look at this written as 3 squared, the 9 that I've got at the front, x minus 7 all squared, I can write it as 3 bracket, x minus 7 close bracket all squared, which of course is going to be 3x minus 21 all squared. And then, of course, I put the 3x inside my bracket, and my 3x is 61 minus 8y. So a lot of this kind of, that 9 that I stuck in there takes a lot of thinking. One could actually put here divided by 3, take the calculator and, I don't know, toil it out, line upon line upon line upon line of tedious algebra. Is that a good mathematician? The answer is absolute crap. mathematician, he should be doing shoelacing techniques and no mathematics. Okay, so I told you I want to be very snappy because I've just, as I said, I'd recorded this video already and I didn't press the right button. Anyway, let's go back and away from our problem. So this is in fact a 3x minus 21 all squared, and you saw the workings for that, plus 9. Do I times this out? No. I'm gonna hold on to that. And again, 73 times 9 is 7 9s, which is 630. 3 9s is 27. That's a 657 or whatever that is. I have no interest at the moment. You can write if you want 657. You can do more tedious algebra in there, but I'm gonna hold on to that because, of course, I know how this question has been structured. I mean, I made the question, so I know what should really happen in here at the end. It actually suits me to leave it like this. So we're going to have a 3x minus 21, and now this 3x is 61 minus 8y from this line here. That was the whole point, in fact, of doing that. And again, no manipulation for that. 73 times 9. And then I have 61 take away 21, which is 40 minus 8y, as expected, well, as I was expecting to happen. And again, if you look at this, another beautiful manipulation, you need to see these kind of things. 40 minus 8y all squared. I'm going to factorize a minus 8. Let me just put the outer bracket first of all. So that's how bracket squared became square. Pull out a minus 8 is going to give us a y minus 5. Just check. Minus 8y there, plus 40 all squared, which of course is going to give us minus 8 all squared, and of course that, which is of course that. And this quantity beautifully does two things. The first thing, I have a common factor. I'm going to put it together, the bracket, of course. And secondly, I go 64 plus 9, which of course is 73. So that's 73. Let me just write a little bit cleanly. Pardon me. It will divide through 73 lots of y minus 5 all squared is equal to 73 times 9. Divide by 73. Y minus 5 is equal to 9. So y minus 5 is either 3 or negative 3. My y will be 8 or 2. And my x, remember the x was 61 minus 8y divided by 3. Now I'm going to write like that so it's in front of me so I can get the corresponding values of x. 8 times 8 is 64, minus 3 divided by 3 is minus 1. And if we put in there 2, 16, 61 take away 16, 6 take away 15 is 45 divided by 3, 15. And this is the problem that we located earlier on in the diagram. We don't have a unique answer. Well, the answer is unique, it's just that this algebra did not produce quite the answer that we wanted. We found that the point is either minus 1, 8 or 15, 2. And we'll finish this problem by returning to a diagram. That's for the year 12s, of course. The approach that if I was just had year 12 knowledge, I say, listen, this is what this thing looks like. We have a set of axes, boom and boom. And let's put the point, the center is at 7, 5. Let's say somewhere here. That's the point P. The rotation of point, the image, sorry, the object rather, is at 4. So it's more to the left, and at negative 3. So it's down here somewhere. So that's the point Q. 4 minus 3. So my original picture was nowhere close to. Remember, this is not to scale in the sense that I'm counting steps or anything like that. I just want to see relative, where are the points. So the point will be something like that. And that's the point that I just found. PQR, I think I called it. And this is either -1.8 or 15.2. Well, quite clearly we can see it's 15.2. My only my justification is that the x-coordinate has to be greater than 7, and therefore that's the coordinates in question. In an exam, for example, something like that, the math scheme will just say, not necessarily with justification, it will say candidate rejects the point -1.8 and concludes that this is the answer. For example, the other point is somewhere there, quite clearly, not to scale, that's the -1.8, so it's on the other side. So not to scale, as you can see, that turned out to be a bit longer in order to fit the picture. Okay. The question's been done, quite a lengthy question, involves a lot of thinking, but I want to show you, this is a little treat for the further mathematicians. And how would you do as a general mathematician? I mean, if you take somebody who is not tied to any kind of like board, syllabi or whatever, if you gave me this question, for example, will I be doing what I've just done in there? The answer is no. What I would have done a completely different approach. And for this, I'm not going to give you any clue. You require just basic further maths, and have a look at my approach and read my mind. The first thing I'm going to write in bullet point form, is rotation, rotation, about origin 90 degrees anti-clockwise. Try to picture if we're rotating, this is your I, this is your J. Your I will go into J, so it's rotating, and your J will go into the -I. So I goes to J, 0, 1. J goes to -I, -1, 0. This is the matrix that rotates about the origin by that amount. The problem is we're not rotating about the origin. We're rotating about the point 7.5. So the next line is quite a joke, really. Translate P onto O. This is very interesting. 7.5. Take away 7.5. It gives me 0, 0. I'm just fighting for completeness. But of course, all the points that I have in there, they need to translate by the same amount. So the next thing, we also need to translate now the object not onto the origin, don't write stupid things, by -7.5, i.e. take the point that we need to rotate, which is 4 - 3, and subtract 7.5 to give us the point -3 -8. So basically now I have a new position for Q. So you can say this is your new point Q, but now it's rotated about the origin, which is very easy. 0 - 1, 1, 0, -3 -8, nothing, 8, and -3, nothing. So this is now the image of the new Q. And now translate back the image. And of course, to translate back the image, we need to take the 8 - 3. When we translated it one way, it was the vector minus 7, minus 5. I wrote the minus at the front. So this time we're going to add it to take it back to where it should be. And you can see what happens, i.e. the point R is 15.2 as before. And this is the beauty of maths. I did promise for the further mathematicians and for those who are in touch with matrices, deal with quite a complicated problem in, I don't know, I mean, I wrote here a full solution and I discussed it in 5 lines and that was it. Okay, I'm going to be signing out. I hope I recorded this time and I'll see you real soon. And till that time, bye.